Okay, so department contacts and resources. I guess these are the two faces you'll and two people names you'll all see, Joanne and me. Okay, academic requirement. These are parts I guess you're most interested in. So you're required to complete 25 coursework units. Units are the part of the leadership curriculum that is administered by Fang Institute. You will take either before the fall semester or in the winter break, right before the spring semester. You have to take 12 units of graduate classes. That's more or less 4 classes, because typically our classes are 3 units, and even if you had a class of 4 units, then it still ended up being 4 classes. Usually students take the 2 classes in the fall and in the spring. Well, that's up to you, up to your bandwidth, how many more you still would like to take to satisfy the requirements, and how many more other classes you would like to be an observer and so on. The capstone project, those are 5 units, of which 2 units in the fall and 3 units in the spring. And a slightly different for different department is the way the comprehensive exam is administered. Other parts are pretty much the same, so comprehensive exam format is different. So everybody has to go through a comprehensive exam. There are 2 components. One is the leadership component, and again, this is administered by Fang Institute. They take care of everything on that side, and any question you have, you should ask Fang Institute on that side. And then that's a technical area that is on our any department. So in our case, the exam is a written exam, 90 minutes, 90, 1.5 hours. So we want to test that you have some basic understanding of the fundamental areas in nuclear science and engineering. For example, what are different ways gamma rays interact with matters, and how does a generic light water reactor looks like, and things like that. So we have a handbook that describes all of these. Probably later, after you accept our offers, Joanne will share all this information with you. So if you already have a background or degree in nuclear engineering, then these classes should be easy and straightforward. Especially the comprehensive exam. We are not going to test any difficult calculation, but just general level of knowledge understanding. We have suggested reading materials, but for people who does not have an undergrad degree, who never taken any class, we suggest you to take the NE 200M mezzanine class. It is a mixed class between undergrad and master's students. Introduction to Nuclear Engineering and Technology. This will help with the comprehensive exam. Will cover all of the knowledge we're going to test. So it's taught alternatively between me and Professor Scala. And this fall, if you decided to come to Berkeley, you will see me in the classroom because I will teach it this round. So 12 units you could do with 3 class or 3 class of 4 units or 4 class of 3 units, or most of the time people do 4 classes. Right? There are several classes that does not count. Those are related with instructed research classes. You do research with specific extra research on top of your capstone project. On top of that, you want to do some extra work. You're so interested in one direction. I had a student who did research with me and later became a PhD student in the group. So these are the research classes that does not count. Okay, 295, 298, 299, 375, they do not count toward the 12 units. So I already mentioned some of that. 2 semesters, you have to do a capstone project. For the capstone project, is most of the time it's 3 to 5 students, depending on the project number. You can either join an NE capstone project or a capstone project outside of NE. Hopefully, it's still related. So you work through the project over 2 semesters. Fang Institute is going to guide the structure of the project and the timelines. Uh, So about some estimated hours per week is probably 6 to 8 hours a week working on the project. Then you ramp it up to 9 to 12 hours a week in the spring, right? 6 to 8 in fall, 9 to 12 in spring, depending on because of the units you're taking for this capstone project. And comprehensive exam, already mentioned about that. 90 minutes written exam. So the book that we recommend is available online. Once you have a Berkeley account, you'll be able to get the electronic version from the library. That will also be the book we'll go over in the 200M class. You don't have to buy the book. Again, the level of knowledge is quite basic, not much of a calculation. So I already mentioned this. Take 200M if you do not have the nuclear background. So the exam is usually offered in the December to January timeframe. For example, last round, the first round was in December, mid-December, right after the end of the course instruction. In case you don't pass, you get the second chance to try again in March. So we just had this second trial of the comprehensive exam. And I think everyone did very well. Well, most of people did well in the first rounds, and a few people who didn't do well in the first round, they normally do very well in the second round. This is what I observed in the past 2 years. Okay, concentration area, we already talked about that. So we have some recommended full set of classes for each concentration areas, which we can select from. There are more than 4 courses per concentration area, so you can pick depending on your specific focus of, for example, the capstone project or your future career. For example, you want to focus more on reactor design, you can take more on the thermohydraulics part, risk analysis part. If you're more interested in the radiation detection, you're more than welcome to take the radiation detection class and maybe some shielding or radiation calculation related, transport related classes. The general process for the capstone project, the general process is pretty much like a two-way match. So basically, what you do is like when you're applying for a job, more or less. So you go in the market, in sometime in August, there will be a link shared with you. You go in the marketplace and mark the interested projects from most interest to least interest. I think you get to pick like 4 or 5 different topics. And then try to explain why you're a good fit for this project. What's your knowledge background? What's your interest? And then there is a matching algorithm between the project and your applications. In general, you submit your CV and all request materials for that matching process, right? Then you have your ranking, your priorities. After you apply, uh, then the instructors come back and soon take a look of the applications, and they also mark their preference of the students who already select their project, like 1 to 5. Um, and then after that, the system, well, they have some very sophisticated algorithm to do the match between the two sides. Either by using the data of the students' ranking and the instructors' ranking to really match the student with the project. As I say, it doesn't have to be a capstone project in the nuclear engineering, but if you take a capstone that is not sponsored by nuclear engineering, then you have to notify me, the MEng lead, for the approval. For example, saying something like, well, Professor Su, I want to take my capstone, for example, at mechanical engineering or computer science for whatever topic it is, then I need to approve that. Right? We still expect that there is some relevance to nuclear science engineering. For example, if you take heat exchanger design and mechanical engineering or turbine blades corrosion thing in material science, I'm okay with that because that's relevant. But if you want to do some AI assisted high frequency trading for stock markets at ECS, I will most probably not approve because it has nothing to do nothing to do with nuclear science and engineering. Maybe some nuclear startup company stock price, but that's not science and engineering for me. Okay. So some examples of the project we had in the past, they tend to cover a very wide spread areas. For example, Professor Pierre Peterson advanced reactor control and remote autonomous operation. That's 2 years ago. I probably should update it. Last year, Professor Peterson posted a very interesting topic that is to design a nuclear reactor for maritime applications, to put the nuclear reactor on the cargo ship. Professor Abergel designing new phantoms and holders for medical imaging and radiotherapy applications. Professor Peter Holzman, he always posted something on the 3D metal printing direction. And after you graduate, many students go to the industry. Most of them have quite successful and related career in nuclear. For example, last year I had a student going to nanonuclear, and the year before last I had a student going to Helion. Helion is a fusion company based at close to Seattle, right? And we also have students go to Kairos Power. Also, many students they also choose to stay in Berkeley or somewhere else to continue their graduate study. So these are all very good choices for your future career. Okay, last, thank you for joining this info session. I hope you'll choose Berkeley Nuclear Engineering. And we're about the time. I don't know if we have time for Q&A, Joanne, but this is the end of my presentation.
Yeah, let me stop the recording.